Okay, so for this question, I'm going to show you two ways to do it. And the second way is the easiest way, but it requires a little bit higher level thinking. Okay, and actually, I think you guys could do it. So for 64, we'll do the same. Well, I'll start off the same way. Well, let's see, 64. I can divide 64 by 2 because it's an even number, and that's 32. And I can divide that by 2, and that's 16. I can divide that by 2, and that's 8. I can divide that by 2, and that's 4. And then I can divide both that by 2 and 2 times 2. So that leaves me 2 times 2 times 2 times 2. Let's see, that's 1, 2, 3, 4, 5, 6. And then I have two z's. So z times z. And then I see there's no number written for the index, so I know that's 2. So I'm going to circle groups of 2 here. So here's a group of 2. There's a group of 2. And there's a group of 2. That means there's going to be no 2's left underneath. And then I see one group of z's, a group of 2 z's, and there's nothing left. So that tells me there's no more numbers under variables underneath the radical. So I'm pulling out 1, 2, 3 groups of 2. So 2 to the third, or 8. And I'm pulling out one group of z, which is just z. So that simplifies to 8z. Now that seems kind of simple. Is there an easier way to do this? Well, what we did a little earlier this year is we said, okay, we broke this up to square root of 64 times the square root of z squared. Well, what's the square root of 64? Well, it's 8. And what's the square root of z squared? Well, if you think of this as let me undo that. If we think of that as z raised to the second, that exponent is the exponent here, divided by 2, because the radical, the index is 2. 2 divided by 2 is 1, so that means there's just a single z. So either way works. Notice we got the same answer. I really don't care which way you do it. Let's make sure I got this right. And I did. Okay, so that's how you do that problem. Hopefully you can do your version.